Hello lovelies, in this video we're going to be looking at vectors for your A-level maths. Now there are lots of questions here worked through really slowly at 3 different levels, so you can jump in wherever you feel most comfortable.
Vectors have got two elements. They've got a direction and they've got a length. So on the diagram we can see two vectors. We've got vector A and it's represented with a lowercase a. So the uppercase A, you see, is for the actual point A. You've got point A, B, C, D, and so on. The lowercase, that's for the vector. Now, what this means is, when a vector is a distance and it's a direction, is that you can have vector A in other places on the diagram. So, for example, between F and G would also be vector A. And also between I and J, or between K and L, or even between J and K, all of these are the same vector, vector A. We've also got vector B on the diagram, and a B is a different length and it's a different direction. Again, other places on the diagram that are the same length and the same direction would also be vector B, for example, between D and H. So one thing that's not part of a vector is a position. It can be in any position, but they've got to be the same length and the same direction. So let's have a look at the question we've got. So we want to start at A, write the vector from A, and going to M. So let's highlight that. We're starting at point A. Notice these are uppercase, these are the points, and we're ending at point M. So to describe this using a vector, we are only allowed to use vectors that are labelled on the diagram. You might be able to see that to get from A to M, you want to go from A to E, from E to I, and from I to M. Now we know that A to E is vector B, so that means that E to I is the same direction, it's the same length, this will also be vector B, and I to M will also be vector B. So to take that full path, we're going to do a vector B plus another vector B plus a third vector B. Altogether, that's going to be 3b. So we write this, if we say the vector from A to M is equal to, and we have a little arrow above it as well to show that it's a vector. So we write it like this. The next vector we'll look at is a vector from point O to point N. So we can label those in the diagram. We're going to start at O and we're going to end at N. So the shortest distance in between the two, starting at O and going to N, is what I'm labelling on the diagram. Now, can we see any labelled vectors that are the same length and the same direction? And make sure we're starting at O and ending at N, so this is the direction we're going to go in. Now, you might have noticed that vector A is the same length, but it's also in a different direction. Now, the direction is related, it's just the kind of opposite way around. The arrow's the other way around. It's not a completely random other direction like B is. B goes in a completely different direction. So what do we do? So we're going to say the vector from O to N is equal to, it's the same length as A, so we are going to write A down, but we're going in the opposite direction. So we put a minus on. So the vector ON is equal to minus A. It's the same length as A, but it's the opposite direction. Use a negative for an opposite direction. Next, we're going from E to B. So we want vector EB. So looking at the diagram, we are starting at E. We are ending at B. Now, you might want to take a direct route. You might want to go directly diagonal from E to B. And so that would look like this. Now, we are actually not allowed to use that route because it doesn't follow any of the labelled vectors we've been given. We can only go in the same direction as vector A and vector B. So we can't go diagonal. So what do we do instead? So what we can do is we could go backwards down vector B and forwards down vector A. So let's write that down. Backwards down vector B and forwards down vector A. So we call it negative B plus A. You might see this written another way as well. You can actually write it the other way around and do A minus B These represent the same thing. The A is positive in both, the B is negative in both, but if you write the positive number first, then you don't need to write the plus sign at the start. If there's no symbol, we assume it's a plus. So you can actually write it out a little bit shorter. Now, actually, look at the diagram. You don't have to go up and then to the left. You could also go to the left and then up. And you'll notice it gives you the same answer. We go along vector A, then we go backwards down vector B. So what you'll see is no matter which way you take to get to the answer, you're still going to have exactly the same answer. It's not going to change because you went a different way around. It'll cancel out any kind of changes like that. Next, we'll start at F, and we're going to end at P. So this is going to be the vector FP. We want to represent it using the lowercase vectors. Now, again, you might be tempted to go direct from F through to P. We don't have a way to travel diagonally like this, so again, we cannot go the direct route. It's not going to work. We don't have anything to represent it with. We can only copy vector A and vector B. Now, there's more than one way to do this. So, for example, we could go F to G, G to K, K to L, and L to P. So that's going A, B, A, then B. So we've done 2 lots of A, and we've done 2 lots of B. And that's our final answer. Now, you might have noticed other ways to do this. So let's rub this out and have a look at some other ways and see what answers they get. So we're still starting at F and ending at P. What we could do is we could do F to G, G to H, then H to L, and L to P. Now, if we go that way, we're going A, a second A, B, and a second B. And you see, we're getting exactly the same answer. And this is what happens with vectors. No matter which direction you go, as long as you start and finish in the correct place, and you follow the routes of established vectors like A and B, you will always get the same answer. The next question starts at P and ends at I. So again, we can't take a direct route, we can only follow A and B. So we can only follow the actual lines that are drawn on here. So to get your answer, you could go P to O, O to N to M, and M to I. So tracing at each one, we're going backwards down A, and again, and for the third time, and then we're actually going backwards down B as well. So we'd call the vector PI negative 3A take away B. Now again, let's have a look at the alternate routes and see what happens. Now, what if we went completely out of our way? What if we went all the way up to the top, then went across and down and across, maybe going back up? We're really making this the worst route possible. What happens if we take a completely unrealistic route like this? Well, we've gone backwards down B 3 times. Then we've gone backwards down A, minus A. We've gone forwards down B, backwards down A, backwards down B. Then we've gone backwards down A, forwards down B, and forwards down B again. So absolutely ridiculous route. So let's count up all the negative B's we've got. We've got 1, 2, 3, 4 negative B's. Let's count up the positive B's. We've got 1, 2, 3. So altogether, negative 4B plus 3B is negative B. Let's look at the A's. So we've got 1, 2, 3 negative A's. That's all we did. We only did 3 negative A's. Well, that was negative 3A. And you see, we're getting exactly the same answer, even if we go ridiculously out of our way. So never worry with vectors about going the wrong way, because again, as long as you use the vectors you're given in this simple A and B, you'll always get exactly the same answer. Now, the grids that vectors are on are not constant, so it completely depends on what question you're given. So here's a different grid, we've got a different vector A and B. So this one's going from A, point A that is, to D. So we can see we take a direct route, we're going down B, and then we're going down a second B. It's the same direction and the same length as B. So vector AD is equal to 2B. So all the rows work exactly the same, even if the grid is different and the vectors are different. For the next question, we'll go from B to E. Now, his first thought might be to go along the lines directly from B to E. But there's a problem, and you'll notice that there's no label for this line. Vector A is in a completely different orientation. It can't be vector A. You might be tempted to say it's vector B, but we look at vector B. While it's the same length, and actually A is the same length as well, it is in a different direction. It might be the same gradient, it's the same steepness, but it is a different direction, so we can't call it B. So what do we do in a situation like this? Well, it's just that we are not allowed to go in that direction. Yes, there might be a grid line drawn for it, but there's no name for it, so we can't do it. We're going to have to go out of our way. So what we could do is we could go from, let's say, B to C, and C to D, and D to E. Now, there are lots and lots of different ways to get from B to E, but they're always going to give you the same answer. Now, looking at this one, I actually can't use this either, because going from C to D, that's that same diagonal line that I couldn't use before. So I can't go from C to D. What else could I do? Well, I could go from C to O, and O to D. So let's look what that's given us. B to C is vector B, same direction, same length. C to O is the opposite way down A, it's minus A. O to D is the same as B, and D to E is another minus A. So we can say that vector BE is equal to, so we had two B's and we took away two A's. And that is our final answer. So again, don't be worried about going far out of your way. You'll still get the right answer. But don't go down routes where you don't have a labelled vector. That's not allowed. Now, for this question, we're going from B, then we're going to the midpoint of A and B. This is a new thing we're introducing. Now, the midpoint of A and B is a point exactly in between A and B. Now, the way to think about this is that vector A from A to B has the direction and it has that length. Now, we've looked at things already like going from F to O and O to C. That's the same direction as A, and it's twice the length. So we can call this 2A, it's twice as long. Now, what if we went from the midpoint of ED to D? This is half the length of A. So we can call this half A. So we can have halves as well. So we can see that going from the midpoint of A and B to B, it's half the length of A. And we can see that up at the top. So we can say that the vector from B to the midpoint of A and B, so let's call this midpoint M, let's give it a letter. So we can say the vector BM is equal to half of A. So let's do another midpoint question. Well, the vector from D to the midpoint of O and E. And we can label that midpoint M. So how are we going to get there? So firstly, you see M is in between E or O, so we need to get to E or O first. Doesn't matter which one we go to. Let's go along the bottom here. So we can go from D to E. And now we're as close to M as possible. We can go halfway along that line to M. So what have we done? We've gone backwards down A. And then, looking at this, actually, this doesn't have a label. We can't go in this direction. So this is a little bit of a dead end. So there's going to be a different way to do this. Now, another way of thinking about this is this midpoint here. It's also another midpoint. In between E and O, it's also the midpoint of F to D. So if it's a midpoint, it's halfway. So if we actually went up from E to F, that would get us the full length of DF. And we don't have direction for this one, it's the opposite way down B. It's minus B. So this midpoint is actually half of this. So we can say from D to M, well, we could say from D to F is minus A minus B. So D to M is halfway of that. So we can say it's half of minus A minus B. For our last midpoint question, we're going to go from C to the midpoint of E and D. So we're going between E and D and label it M. If M's already used, by the way, you can use any letter you like. So how do we get this? Again, try and get as close as possible first. Now you might want to go from C to D, but that's not labelled with a vector, so we can't go that way. So we could go from C to O and from O to D, and then we could go across to M. So let's check if this is possible. C to O is minus A, O to D is B, and D to M, that's going to be half of minus A. So we can write down our vector from C to M, that's going to be, so we've got minus 1.5A altogether, and we've got 1B. And again, as usual, you can see this is the way around. You could do B minus 1.5A. Just by putting a positive number at the front, you don't have to write the plus sign, so it's slightly shorter. Vectors like this aren't limited to grid patterns. They can be on anything you like. So here we have it on a triangle. So what the vector from T to S, it's going to work exactly the same way. You only allowed to travel down lines that have a labelled vector. So for example, we cannot go from T to S directly because there is nothing labelled in that direction or that length. What we can do is go the long way around, and we can go down Y and go down X to get to our location. Now, when we do this, we're going the opposite way down Y. We're going the wrong way. That'll be a minus Y. We're going the correct way down X. That'll be a positive X. So we can say the vector TS is equal to negative Y plus X, or alternatively the other way around, so you don't have to write the positive symbol. For the next question, we have a different size triangle, and we're going from C to the midpoint of B and D. Again, all the same things you find on the grid vectors, you can find on vectors like this as well. So label the midpoint M, and to get there, we can travel down vector X, and then we can travel halfway down vector Y. Check your directions. We've gone the wrong way down X, it'll be negative, but we've gone the right way down Y. So it's going to be a positive half of Y. So altogether, we can write that down. Vector C to M is equal to half of Y minus X. Now you might be wondering why we're allowed to swap the positions of the X and the Y, because we did X first and then we did Y. We just swap them around so we don't have to write the plus sign. Now, if you just think about it, if you do half of Y starting at C, you're going to end up around about here. And then if you take away X, it's going to be parallel to the other X. And actually what's going to happen is it's going to get you to that location. So even if you actually rearrange the order you do it in, you're still going to end up in the right place. The next question was starting at the midpoint. That's the midpoint of C and D. So let's label that. And we're going to B. So what we need to do is, you can think of it going from B to C, but then we can't go down the line that ends on because there's no labelled vector for it. It would be the same going the other way around. So there's no way to get to M as we're looking at it at the moment. So what we need to do is actually think about this in a bit more detail. So this midpoint, it's the midpoint of C to D. So if we could work out C to D instead, because at the moment we're trying to work out B to M. If we can work out C to D, then what we're looking for is going to be half of that. So C to D, what we would do is we would do, second at C, we do negative X and then positive Y. So we can write it as Y minus X. So C to M is going to be half of that. So it's half of Y minus X. So now we've worked out what C to M is, now we can actually do the root. So let's rub out our lines we've used so far. So starting at B, we're doing B to C, which is X. And then we're doing C to M, which is what we've just found. It's half of Y minus X. We'll write that down, I'm going to expand the brackets as well. So we've got X plus half of Y minus half of X. All we need to do now is collect up the X terms. X take away a half will give us a half. So it's half X plus half Y. So the thing to learn here is, if there's no way to avoid going down a line you can't go, like C to D is not labelled as a vector, then what you can do is actually try and work out C to D first, using other vectors, and then coming back to it. You'll also notice a little pattern. From B, we can see we've got X going in one direction and Y going in the other direction. Now, we're going to this midpoint, and you might be able to see that half X plus half Y actually goes in between those two directions. The next question has two midpoints. What the midpoint of K and L and we label that one M. And we have the midpoint of K and M. Oh, hang on, we've already got M, haven't we? So I can't label it M. So let's change that label. So we could use anything we like here. So why don't we just use A and B? So let's use A for the midpoint of K and L. And let's use B for the midpoint of K and M. The midpoint of K and M is going to be here. So give things labels so you can tell what you're doing. So we're starting at B. So we could go down to K. We are allowed to go this way because we're going down the Y direction. And then we could go up to A. And we're allowed to do that because that's the X direction. So we've gone the wrong way down Y. So that'll be negative half of Y. Then the correct way down X. So that'll be a positive half of X. So the vector from A to B is going to be half of X, take away half of Y. For our last question, we're going for the midpoint of D and E. Let's call that M. And then the midpoint of E and F. Let's call that N. So we're starting at M and we're ending at N. So first, see the direct route is possible. It was in the last question. It wasn't in the one before. So we could go from M to E, but then we can't go from E to N. There's nothing labelled there. So getting to N is going to be a little bit tricky. So why is it tricky? Because we don't have anything labelled for E to F. So let's find E to F first. So for E to F, what we could do is we could go backwards down X and then forwards down Y. So that'll be Y minus X for E to F. And now we've got something for E to F. Now we can go from M to N. Important to know the direction you went as well. So what we probably want to do here is we want to go from M to E and then from E to N. So looking at that vector, M to N, we're going halfway down vector X. We're going in the correct direction, so it's positive. And then we're going halfway along E to F. So we're going to add on half of what E to F is, which is Y minus X. We need to expand the brackets, so we've got half of X plus half of Y minus half of X. What you'll notice here is the X's actually cancel out. Half of X take away half of X is 0. So we only have half of Y left over. Now, does that make sense? Well, if we actually trace out the direct route from M to N, you'll see it's parallel to Y. And you can see on the diagram it's roughly half the length. Now what we've actually done here is we've proven that M to N is parallel to D to F. So an alternate question might say, prove that it's parallel. And we've proved it's parallel because it's the same vector. It goes in the same direction. It's just a different size, and that's okay for parallel. It wouldn't be parallel if there's an X involved, because X will make it go in a different direction.
Ouch! This is why in some videos I explain scratches.